All right, hello everybody. Welcome back from the snow day we had. We were on lesson 12, and we're going to keep going with lesson 12, and we're going to finish it up today. And lesson 12 was talking about properties of inequalities. So, our objective was to understand what an inequality is and to know what it means to preserve an inequality symbol and to reverse an inequality symbol. So last week we talked about what preserving an inequality symbol meant. Excuse my crooked writing. But to preserve an inequality symbol just means to keep that the symbol stays the same. We were talking about what preserve means. Preserving means to save something so that the symbol is saved. It does not change. But when an inequality symbol is reversed, that means the symbol switches directions. So we're just going to look at a couple of examples on each page starting on 81. Not going to do all four, but we're just going to quickly do these just to see what happened when the symbol was preserved and what happened when the symbol was reversed. So say, for instance, I wrote a negative 6 and a 3, excuse me. So I would just say which one is bigger. Of course, any positive is bigger than any negative, so 3 is larger. So let's add negative 3. So I've got negative 6 plus negative 3, and then I've got 3 plus negative 3. So this would give me negative 9. This would give me 0. Which one is bigger? 0, so it was preserved. All right, now let's look at 4 and negative 3. 4 is bigger, naturally. So let's subtract negative 1. So this is going to be 4 minus a negative 1. And then this is going to be negative 3 minus, oops, I did that wrong, but that's okay. Minus a negative 1. That's a little mistake there. So remember, this is like adding the opposite. So this is like 4 plus 1. So that's going to be 5. And then negative 3 minus negative 1 is like negative 3 plus 1. So this is going to be negative 2. Which one is larger? 5, of course. So our symbol is preserved. So examine the results. And all of these should have been preserved. So we're going to write, and I'm going to turn this a little bit so I can write here. Okay, so make a statement about what you notice. So all inequalities were preserved. And what happened on this page do you think that made the inequality symbols be preserved? Well, we were just adding and subtracting positive numbers and negative numbers, as you can see. So we're going to write all inequalities were preserved when adding and subtracting. And we're just going to write integers because integers covers the scope of positives and negatives. Okay, let's look at the next page. The next page was station 2, and we were multiplying by negative 1. So let's look at what happens when we roll a 2 and a 3 and a 4 and a negative 1. So, which one's larger out of 2 and 3? Of course, 3. Now let's multiply both sides by negative 1. 2 times negative 1 and 3 times negative 1. So 2 times negative 1, negative 2. 3 times negative 1, negative 3. Which one is larger? Remember, when we're dealing with negatives, the more right you move, the bigger the number is. So negative 2 is to the right of 3. So negative 2 is bigger. Look at the symbol. First we started with less than. Now we have greater than. So it's reversed. Let's look at 4 and negative 1. I don't even know why I skipped the space here. That was kind of unnecessary. But hey, same difference. Which one's larger? Of course, 4. Let's multiply both by negative 1. Negative 1 times negative 1. This will be negative 4. This will be negative 1 times 1 is 1. Which one's larger? Of course, my positive. Look at that symbol. Up, up. It was greater than. Now it's less than. So it's reversed. All right, so here is that question again. Examine the results. Make a statement about what you notice and justify it with evidence. So if you completed Station 2 last week, all of these should have been reversed. If it wasn't reversed, then it must have been something going on with the math. So all inequality symbols were reversed. And what was happening, do you think, that caused this to be reversed? Well, all of these we were multiplying by -1. So it must be that when we multiply by a negative number, or a -1 right now, we don't know if it works for all negative numbers, but it must be that when we multiply by a -1, that flips the symbol. So all inequality symbols were reversed when multiplying by -1. And that's just what negatives tend to do to things. When negatives get around things that are positive, they become negative. And when negative gets around other negative numbers, when we're multiplying, that is, they become positive. Okay, let's look at Station 3. So Station 3, adjust my camera here. Station 3, looks like we're multiplying and dividing by some positives. I wanted to do this divide by 1/2 just to kind of remind us how to divide by fractions. So here we have 5 and -1. Which one's larger? 5. And you can put this in your notes if you don't have this station filled in. Please, please, please put this in your notes if you don't have it. So 5 is greater than -1. Let's multiply by 2. So we've got 5 times 2, and then we've got -1 times 2. Let's do the math. 5 times 2 will be 10. -1 times 2 will be -2. 10, of course, is greater than -2. So our symbol started with greater than, still have greater than, is preserved. Okay, and let's go down to this divide by 1/2. I wonder what's going to happen here. So 6 is greater than -3, of course. Now let's divide by 1/2. So I've got 6 divided by 1/2, and I've got a -3 divided by 1/2. When I'm dealing with fractions and I'm dividing, let's put it over 1. Let's take one at a time. Remember, when we divide fractions, we're going to use the multiplicative inverse, or that reciprocal, because dividing fractions, all it is multiplying by the flipped version of it. I'm going to zoom up so you can see that really well. So this is really going to be 6 times flip 1/2 and get its reciprocal, and that's going to be 2. And 6 times 2 is going to be 12. Now let's look at 3 divided by 1/2. So, or -3 divided by 1/2. This is going to be -3 over 1 times, let's flip it, 2 over 1. And since they're both over 1, that means it's just going to be itself. So -3 times 2 is going to be -6. Now, which one is greater, 12 or -6? That's going to be 12. Any positive is bigger than any negative. So our symbol, was it preserved or reversed? It was preserved. It stayed the same. It was saved. All right, here we go again. All of these at Station 3 should have been preserved. And it says, examine the results. Make a statement about what you notice and justify it with evidence. Well, it looks like here all of our symbols were preserved. So let's put all inequality symbols were saved or preserved. And what was happening to preserve the symbol? It looks like we're dividing and multiplying by what type of numbers? By positives, it looks like. So all inequality symbols were preserved when multiplying and dividing by positive. And look, we've got 1/2 and some whole numbers here. So let's say by positive rational numbers. And it says justified with evidence, but our evidence is here in our work that we've been doing. Okay, so let's look at station 4. Okay.